Magandang araw sa inyo matatalinos. Magandang araw sa inyo matatalinos. Ooh, there you go. All right, good. Good day to all of you smarty pants. Did it sound like you can understand it? If I try to say it and I'm not just shouting, Magandang araw sa inyo matatalinos. You can understand it, and I sound like I'm from Manila. I know. It's oddly fluent. Okay. Cool. Well, we only have one type of problem left to do, and it's not terrible. Today, I tried something in Calc that I think we're going to try in here, because it's an issue. If we do a bunch of stuff up at the boards, like people who are out can't see it. But what's really cool is when I put you guys in groups, if I wanted a group to write up here, all I have to do is give you the Bluetooth tablet that I have and hand you a microphone. And then now your whole group conversation goes on the YouTube channel so that people who are on the road have the chance to hear and see it if they elect to watch it. Anybody want to volunteer to be the group that writes on the tablet? Awesome. I love that somebody volunteered. Okay, so we'll see how this shakes out. We have one more problem to look at. Okay, so I'm just trying to catch up to yesterday. Are you sure we didn't have homework? Yeah. Okay. All right. Fair. So today I'm trying to find my notes and I'm stalling a little bit because I don't know where they are, but I got them here, so that's okay. Let's do one more. Yesterday we saw a couple new techniques. We can do what to each side? You can exponentiate it. Love it. And you can exponentiate it with 2. And ooh, in hindsight, am I using the wrong word there? I think I might be using the wrong word. And we'll clean it up. That's okay. Because now all of a sudden it's dawning me that I think I use exponentiation differently, which makes more sense to why you were doing logs. Let's square both sides. Let's raise both sides to the same power. That's not really exponentiation. That was a speako yesterday. All right. Let's try a different one. Why was it funny? Just, I agree with it. As opposed to a typo, right? Yeah, there we go. Okay. All right. Let's knock one out. We're going to do another example where, just like yesterday, we are not going to get the name yet because it's going to give it, you know what? The name is not going to give it away. One more example. We're going to do a double or multiple angle. It could be double, it could be triple, doesn't matter. Multiple angle. Now, I'm open to doing stuff on the board today, but I do want to talk about this one at least to get going with it. You guys are all going to help me out. I'm going to give you a 90-second head start with your neighbors. I'll write the problem on the board. I want you to start working through it, talk through it together. After 90 seconds, we should have, maybe not the whole thing, but we'll have a few steps where you guys can volunteer what you'd like me to do. Cool? All right, so we're not going to the boards quite yet, but let's check it out. On our first one, multiple angle, we'll even see what this means. And I'm not going to use pink because that's traditionally for just my scratch work, so I'll stick with that convention. I want to know, when is it true that, ooh, I kind of like that. Yeah, we'll just do this. 2 times the sine of 2t. When is that exactly equal to root 3? Okay, we're going to go 90 seconds from right now. If you want to start working it physically on your page, you can. But I'm going to start calling on people in 60 seconds. But I'm going to let 15 seconds click first. Talk it out. Chat with your neighbor. Get an approach. Cool. We are looking for some ideas here. If I want to solve for t, divide by 2 is everybody's first thought? Okay, so let's just see. What does that give me? What would I write? The sine of 2t is equal to root 3 over 2. Everybody agree with this? Now, here's the weird situation. Why is this problem different than what yesterday's problem was? There is a multiplication in the argument. Instead of just angle t, it's twice angle t, which is what we're taking the sine of. Do we all agree with that? Okay, now, I see people looking at trig cheat sheets. We don't even need the double angle. We do not need the double angle, just so you know. If you've seen it and you're looking at it, that's okay, but we don't even need it here. check this. Can we just pretend for now that this isn't ugly? And I don't want you to change yours, but I'm going to change mine, and I'm just going to work the same problem over here. I'm not even going to change it. I'm just going to do this, a nicer looking problem that's essentially the same. If it was just this, and I'll do this in pink because that's the color that I said I was going to use for this. If it wasn't ugly in the argument, do you agree that that's the same sort of problem, but just much nicer? How on earth would we figure out angles where t is root 3 over 2? You could take the arc sine, but if you can't calculate the arc sine off the top of your head, and you can because you're going to look at what? Unit circle. On your unit circle, are there places where t is the sine of some angle t is positive root 3 over 2? So in this line of work, again, this is a nicer problem. Do you agree that we would just simply say that t equals, what's the first place that happens? And then, did I specify we're working on an interval, or are we just working forever and ever? What's the difference? What would I have written if I wanted some interval? What's the thing? So this is a different problem. I'm just showing us that we're going to take the same approach. You do not need to write this part lay if you don't want to. I just want to show you. This problem isn't crazy. So there's no 0 to 2 pi. This is what our answer would read for one of them. Is there another one? And then, again, this is the same setup, but simpler problem, right? We're just trying to think about how this works. This one would be what? 2 pi thirds? Plus what? Okay. Honestly here, and I need everybody to vote, but you don't have to broadcast it. With the pink problem, which I know we took a sidestep here, for the pink problem, thumbs up says, yep, I'm good with this, I understand. Thumbs down goes, I really don't understand this, and anywhere in between. Okay, can somebody give me a quick summary? How do we decide that t needed to be pi thirds? Yeah, let me try this real quick. I'll get right back, I promise. So if I'm here, here's root 3 over 2, right? Pi thirds. Is that the right quadrant? Okay. If I want to end up right back here, and I'm going to go around a circle, you tell me when I get back to the exact same value. How many radians did I just rotate? So that was like one full circle away, right? What if I'm here, and I'm starting again, and I go, did I wind up in the same spot again? How many radians did it go? I agree. So if n was 2, it's just 4 pi. This is just telling me any number n of full circles past it. Because if we think about the graph, and that's a good question. If you guys didn't hear what Basil just said, why do we have to mention this? Because, don't sketch this. I just want to make sure we can hit it. What does sine look like? What? Sine looks like y, so this is sine? Okay, it's a wave. How far does it keep waving for? So we could, if you guys really wanted to commit to it, we could physically write down every single one of these infinitely many spots until the universe is gone. I don't think we'll still be here, but Basil, do you agree that this, if we're looking for the solutions, x-intercepts, there's a bunch of words. If I really graph all of sine, how many are we going to find? Like, I quit counting here, but I have like 10 up here. Does it keep going further than that? Would we ever stop counting them? So unless you want to write all infinitely many of these, we need a way to say, hey, look, this works, and then just go 2 pi, and this works. And then go 2 more pi, and like we're just finding a way to write all infinitely many of them without physically having to do that. Okay, yeah, of course. Okay, this is doable. This is almost the same thing, except we're going to make one little tweak to it. Rather than saying t is equal to this, all that we require now is our argument, which is what this time? 2t is what should be equal to this. We just need to pick t's that make that our argument. Like, that's what we're finding here. So when we are doing these out, we have 2t equals, and I'm just using the same thing. Just like I'm doing this, we're going to do the exact same thing. We just have one extra step. Is it still, whenever that argument is pi thirds, like if I find a t that makes it pi thirds, I still get this value out. Do I still have to do any full number of circles after that? So we're going to pause here. I'm going to do one thing real quick, and you don't have to erase it. I'm going to add one line in here that, because I can see the blank looks that I'm getting, I'm going to write one statement just for this one problem. If I let u equal 2t, and this is just a placeholder to look nice, do you agree that this is now just the sign of u equals root 3 over 2? Is that any different than if I just called it t? So then I just take this and I set it equal to the values, right? Instead of this, could I say, oh, this is u equals pi thirds plus 2n pi? And then I'm just using it as a placeholder to see we're doing the exact same thing. And then 2t, when I plug it back in, it looks exactly like this line. Okay. If I wanted, though, to solve this, and I'm going to do them both differently, or the same way but separately, just like we did here. This isn't for t yet. I need to solve for t, not for 2t. I can divide, or is there a maybe better way we can think about this operation? If I divide both sides by 2, or if I multiply both sides by 1/2, which is the same thing, what remains on the left side of this equation? And what is it that we're solving for? T. So let's just see what we get. Is there any natural algebra that must happen here between this and this? Yes, multiply. What's pi thirds times 1/2? Plus, and this one's harder, or not, what's 2n pi divided by 2? We do the exact same problem, except for this very end little spot. Instead of just saying t equals, we just use whatever the argument is. If we had to use a substitute here, I'm totally cool with it, but we're still going to have the same step. Like, still has to happen. These are the same answers. Any theta that we pick, if we double it, which is what's happening here, we're going to get these. I want you guys to write me the other solution. Check with your neighbors. I'm going to give you a minute. Get me the other solution as well. And I'm going to leave some room for scratch work, and I'm actually going to freeze my screen and work it so that if you want to see this done in 3, you'll have the answer in 3, 2, 1. Cool. All right. So here's the weird part. I did not have my notes. I know they're in here somewhere. But you know what's more important than the math stuff that I write on my notes? That's right. It's the homework assignment. All right. So let's see. We did not have homework last night, true? I did. Thank you for that. In the long run, I'm going to be honest. I don't really mind if you add these to it, like I told you guys to do the other day, or if you do it on a new sheet of paper. I'm okay with either. Cool. I can remember. Actually, I don't have to remember. Pause. Not really pause. I'm going to pause my video. Here's our assignment. The date is wrong because that's from 2022. But 5.3.2, these problems. Now, it looks long, but again, do we really have to do them all? If you can do the hard version or hard problems in a section, then you can do the easier problems in a section also. Cool. We're going to do the quiz. I'm going to put this on our correct year for Google Classroom. But I'm also going to come around and, ooh, we don't get no cards, so never mind. Easy. But you do get what? Trig cheat sheet. Cool. Quiz is Friday. I'll have it ready tomorrow in case you guys change your mind. But I don't know how I feel about doing 5.4 and then quizzing on the first 3 after you get a whole new section. How much you guys think about that? I'll have it ready for tomorrow if we decide to do it tomorrow or Friday. By the end of the week, we also have to make sure we all agree on who is bringing what pie for the first Monday after spring break, because we're going to miss Pi Day. We're missing Pi Day for spring break, but we're going to celebrate it in here, which is perfect because we're doing trig stuff. Cool.